Alright, so today we'll be talking about determinants and inverses. And first off, we need to understand that the only time you can get determinants and inverses if you have a square matrix. Now, a square matrix is going to be a 1 by 1, a 2 by 2, or a 3 by 3. Or 4 by 4, or continue on. Just make sure that the rows equal the columns in any type of square matrix. Okay. Now, we're going to talk about the multiplicative identity inverse, or the multiplicative identity matrix. Okay, and that's going to be I. Alright, so it's either going to be a singular one like this, 1, 1, 0, 0, 1, or a 3 by 3, 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, in other words, the diagonals from the top left to the bottom right are going to be filled with ones and everything else is zeros. Now the cool thing is if you take any matrix and times it by the identity, you're going to get the same matrix. So it's seriously the matrix version of 1. Okay. Alright, now the multiplicative inverse property, before we actually get to that, we need to talk about something before we get to inverse, and that's going to be the determinant, because the determinant actually helps find what the inverse matrix is going to be. But before we do that, we need to understand how to do the determinant. Okay, now the determinant can be used for a lot of things, and in actuality, the determinant in more proper context is used in higher level maths as what is called an eigenvalue, and you use that in linear algebra quite a bit. And eigenvalues can tell you a lot about a matrix just by looking at an eigenvalue and calculating it. So basically, determinants equal eigenvalues. Oops, let's get rid of this. There we go. So it's an eigenvalue, basically. Okay. All right. Now, for a 2 by 2 matrix, here's what it's going to look like. All right. So a 2 by 2 matrix, to find the determinant of it, we need to understand first. Let's call this a certain letter. All right. So we've already used A, so let's use B. Okay. So if I wanted to find the determinant of B, I could either represent it as determinant of B, or I can use the absolute value marker. Oh, let's go absolute value of B. And that's going to be the determinant. Okay, so either way, it's going to represent that. So if I do the determinant of B, it is going to be 2 times 5 minus -1 times 3. Okay? And you probably want to put the second set in parentheses just so you don't get confused as to what's going on. And so this is going to be 10 minus -3, which is going to turn into 13. Okay? Alright, now, this is perfect because this will actually help us find the actual inverse. Okay, so a lot of things have to go on with the inverse to actually work with it. Now, if you get some number other than 0, you can actually find the inverse. And so basically, if the determinant does not equal 0, then you can get an inverse of that matrix. And if the determinant does equal 0, then you have a singular matrix with no inverse. So it's that simple, ladies and gentlemen. You can actually use the determinant to determine quite a few things in the beginning. Now, a 2 by 2 matrix can easily be done by hand, and if you want to see that again, you're just going to take these two and multiply them first, and then subtract these two. And sometimes you will get a double negative, so that's okay. All right, now let's talk about a 3 by 3 on this one. Alright, so for a 3 by 3 matrix, you're going to think, oh, I just multiply these and then multiply those. But then what about the 9, the 5, the -5, and 3? Okay, so what you're going to do is, here's how to do a 3 by 3 matrix. It's a little bit interesting. I'm going to move these over to the very edge as possible. Okay, so what I'm going to do is I'm going to repeat the first 2 columns again. Okay. Now what I would do is, once you repeat those first 2 columns again, what you're going to do is multiply these all together and then add that with these and these, adding all together. Okay, so it's going to look like this. Okay, 4 times -2 times 7 that is going to be negative 56 plus 9 times 5 times 1, that's going to be 45, plus 0. Now the next part we're actually going to subtract. Now what we're going to do is we're going to go not counterclockwise, but backwards. So we're going to go backwards and multiply these, and then we're going to subtract these ones. Okay, so it's going to look like this. All right, and that's going to look like this. So what we're going to do is we're going to get another 0. So let me see. I think I painted myself into a corner. I'm going to write it over here. Okay, so we're going to minus all of those. All right, so it's going to become minus 0. So that's going to be another 0, not 0. And then 4 times 5 times negative 5, that would be negative 120. Okay, and then minus 9 times 3, which is 27, and 27 times 7 is going to be minus 189. Okay, now when we put this all together, so this would be negative 56 plus 45 plus 120 minus 189. Okay, you're going to actually get a pretty reasonable number, which is negative 180. Okay, and that's how you get the determinant. Now I'm going to show you how to do it on the actual matrix calculator and show you how easy it is. Okay, so once again we are on the matrix calculator. I'm going to show you real fast how to actually quickly calculate this. Now if you're using a TI calculator, that's totally fine. No one's going to be upset at all. Let's make this a -1, and then let's make this 3, 5, and 2. Okay, so if you need to find the determinant, if you remember I showed you these signs earlier, the absolute value like signs, we go ahead and press it and it's quickly done with a 3 by 3. So 3 by 3 is really easily. If I do a 2 by 2, okay, something simple like this, 3, -1, 2, and 5. Okay, I'm just going to press the other determinant button and I'm able to get it really fast. Okay.